Sir, welcome, sir.
సార్ అన్మ్యూట్ అవ్వలేదు సార్ చెప్పండి.
Hello.
Good morning, sir.
Sir, good morning, sir. Sir, is it okay, sir? Sir, welcome, sir. Hello.
Sir, good morning.
Sir, very good morning, sir. Yes, good morning, Dr. G.L. Samuel, sir, and all participants for today's second session on applications of medical applications of robots. Very happy to invite you, sir, again to this faculty development program on robotics.
Thank you, sir.
In association with Aicte, Atal, and as well as Narayana Engineering College, Nellore, Department of Mechanical Engineering, sir. Sir, you all know very well that sir already talked about introduction to robotics as a first session on 14th December from 9:45 to 11:15. Okay. Again, I am warm welcome to sir for today's session also. Already I introduced sir on 14th December as a chief guest and a resource person. Again, I am going to give some very brief introduction about sir for some other participants. Sir, Dr. G.L. Samuel, sir, working as a professor in Mechanical Engineering Department, IIT Chennai. Sir, awarded with postdoctoral fellow from National University, South Korea, and also awarded with PhD from Indian Institute of Technology, Madras, and a master's degree with BDT College of Engineering, Karnataka, and BE degree with same college, Karnataka. And sir also worked with sir is having nearly 20 plus years of experience in research as well as institute as a faculty in various positions in various institutions. And sir have received various awards, and also sir is involved in so many administrative activities, acting as an advisor for PWD and Weaker Section IIT Madras, and member Board of Infrastructure IIT Madras, and also member Board of Studies IIT Madras, and member Placement IIT Madras, and head of the Laboratory Manufacturing Engineering Section. Sir is a life member in MISTE and also Institute of Engineers, Australian Institute of Higher Energetic Materials, and also as a member, executive member in Fluid Power Society of India, treasurer in Single Point Diamond Tool Society. And sir has published a number of papers in national, international journals, and also attended so many conferences, and also reviewer for various books, tool design book, and also machine drawing book, and guest editor for International Journal of Precision Technology, special issue on advances in precision and micro manufacturing. With this brief introduction, I am again inviting you, sir, to this faculty development program for last session. So fortunately, sir started first session and also concluded with the last session, sir. Thank you so much, sir, on behalf of our college as well as Aicte Atal, sir. Thank you so much, sir.
Okay, thank you, sir. Thank you for that introduction. So I think all the participants, you can see the screen, isn't it?
Yes,
Yes,
sir.
sir.
So in the last session also I told, so I'll be interactive and asking questions. So please answer them quickly so that we can move forward. So hope you had a very useful week listening to eminent people from various institutions and industry talking about robotics, their application, so kinematics, inverse kinematics, and all these aspects. So we have also looked at some of the industrial applications of robots while looking at the introduction of robots. So today we are specifically looking at the medical application of robots. But in my lecture, so I would also like to give you some uh, information about the technologies which enable the manufacture of such kind of robots and other applications. Okay, as we have defined in the last class, a very formal kind of a definition we are given, where we defined robot as a manipulator which can move and all those kind of things. But if you really look at robot from that level, so now it has come to a very advanced level. So once we tell robots, we don't just imagine it as a manipulator which is programmable, and that is mostly applicable to something like a pick and place kind of a robot. So it is not that. Nowadays we have such a kind of an advanced robots that if something which can act similar to the human being, so we look at them as robots. So from that level of just a manipulator doing some of the repetitive works, so we have grown into the level. So today we are going to see some of the videos which will give us a better knowledge how robots have been practically working specifically today in the area of medical applications. So the robots, sensors are very, very important. I hope you have studied about some of the sensors which are being used in the robots. Can you name some of the sensors which are used in robots? Yeah, can some names? Sunil Kumar, you are there? Yeah, Kirtika, or anybody can answer. So what are the different types of sensors which are generally used in robots?
Proximity sensors.
You can yeah, very good. Proximity sensor. Yeah.
IR sensor.
IR sensors.
Ultrasonic
Pardon?
sensors.
Ultrasonic sensors. Yeah. Still, one thing which is also more very popular, I also mentioned in my previous lecture. Yeah, tactile or tactile, you call some people, but it is tactile or touch sensors. So, which are very important. So, if you look at the sensors, what the engineers we have developed are similar to what the sensors, sensory organs, what we have in the human beings. So, AI, artificial intelligence, robots, and many of these technologies what have been developed these days are actually there in the nature. I'm also today going to show you some examples of that. So does humans have 5 sensors? Can someone say which are those 5? Yeah. You can unmute and say which are the 5 sensors humans have. Kiran Kumar, Sunil Kumar, Radha, Sunny Kumar. You're all there. Others also can say. So I just
Hearing for hearing purpose, for
Hearing,
observing, as well
yeah.
as for touching, as well
Touch,
as smell
smell, yeah.
and
Vision,
taste.
yeah, taste, vision.
Yeah.
Very, very important. So there are sensors actually to smell So there were, I have also actually seen the development of these sensors, what are called as the artificial nose, because whenever there is a leak in a factory, or if there is any leak, even in domestic, sometimes when the gas leaks, no, so we can keep the sensors which can give an alarm. So like the smoke detectors, we can also put these sensors. So we can put the artificial nose so that it can detect. And in some of the chemical factories, they have even the capability to detect which gas has leaked or what is causing the smell. So thus nose, artificial nose smell is another important one. Taste, though there are some of the sensors which have been developed in food industry, but they are not that popular like what we have. The touch sensor, the vision sensors, which are the most popular one are the vision sensors. So touch sensor, smell, so all the 5 sensors, whatever human beings has, so they have been used on the robots. So if you look at the application of robots in the medical field, so almost whatever the activities what are being done in an hospital are being assisted by the robots. And actually, when I was discussing with some of the doctors, when we were trying to do some work for medical applications, I was surprised. See, we are engineers. I think most of you are here are engineers, and we develop the technology. And do you know which is the field that applies most of our technology right as early as possible? That is nothing but the medical field. So when I'll be talking about micro machining by using a small tools, and I'll also be asking some questions about that. So when we were trying to get the spindles which can use the small tools, we were looking for a spindle. So in engineering and in industry, we couldn't get the spindle. But finally, we went actually to a dentist and we could get a machine actually, which they were using it basically for drilling the tooth. But then we put our tools and tried to machine it, but the cutting force are much higher. In metal cutting, we couldn't do, but then later we contacted some of the German and US companies and we could get the spindle which can machine the metals. It's called as a micro machining by using the traditional or the cutting tools. So thus, we were surprised to find that most of the technologies what we are talking about by engineers are applied immediately to the medical field. And then they have changed the whole medical field. Now, if you go to an hospital, it looks more technologically advanced than when you walk into an industry. Will you agree with this? Yeah, any answer, yes or no?
Yes, sir.
Yeah. So when you walk into an hospital, we see that most of the technology is put to practice there rather than even in an industry. So there's many areas so where the diagnostic, surgery, rehabilitation, so doing some of the procedures, surgical procedures and other procedures, then treatment, pre-treatment, post-treatment and all, in all these things, then even simulation. So the medical simulations and the medical analysis are much advanced than the analysis what we do. So we were actually discussing about the what do you call as pattern recognition. So then we said, as a mechanical engineers, we use vision systems in identifying the parts, so which will have the circular shape or triangular shape or rectangular shape. So these are which are basic pattern recognition. But you know how advanced the medical uh, people are in analyzing that kind of a graphical 3D graphical data. So nowadays, if you go to any hospital, when they take the CT scan, even before doctor comes or looks at that particular CT scan, the computer itself will tell what is the problem. Is it normal or is there any problem there? You know how they does that? So it uses that large amount of data which has been generated and then puts all of them together into a 3D data and then compares it with a normal organ. Like for example, if it is a heart with a normal heart, or if it is a brain, it compares with the brain and then quickly tells what is the problem or there is no problem. Then actually the medical doctor will come and also look at it carefully, and if the computer has pointed out something, they will look at it more carefully, and then most of the time they find that whatever the computer has shown, that is right. In some cases, okay, now that may be some error or something like that, but most of the time whatever the computer indicates, so the doctors will be careful enough to look at that particular part more carefully and see whether it is right or not. So thus modeling and simulation and even an analysis part, so the medical field has used our engineering techniques to the maximum extent, even in guiding the doctors, even caring for the patients. So in our lecture, we are going to look at them. So before we go into the medical area, so we have been working in this area, what is called as a micro manufacturing. So micro manufacturing. If you look at some of the engineering products, so there are several products which have been developed by engineers, and some of them are being used in the medical field. So here you can see one example. So the one what you see here is mini petrol engine. So where you can fill few drops of petrol into this engine and it can run for years. So in US, when they were trying to develop the batteries, so usually in the batteries which come in the watches and all, even in quartz watches, so the life is like 1 year, 1.5 years, or 2 years. So every time we need to change the battery. But now if you have this kind of an mini petrol engine, we can run the watch for almost 10 years with few drops of petrol. So that is how actually they tried and then made at the laboratory level. Then other products, we can see the cameras, tiny cameras coming in all sizes and shapes. So even on a pen cap, you can just have a camera. So that does, you can have a very small cameras, micro shafts, micro needles, so micro pumps, and all these kind of a parts, we can make it by what is called as micro manufacturing. So thus nowadays we see so many micro and even nano products. I think hope you understand what is the practical size of micro and nano. Can somebody give an example to make a person who is a non-engineer to understand what is a micrometer? So did you understand my question? So think that you are doing a lot of research and then somebody comes and asks, maybe from your village, and ask, what is a micrometer? So how do you tell them so that they can understand? Yeah, any quick answer? Yeah.
Yeah, take a size of a hair.
Pardon?
Size of a hair.
Size of a hair. Okay. How much is the size of hair? Diameter?
Sorry, it's nano.
It will be? Yeah. What is the size of the hair? Yeah, please go ahead. Somebody was telling something, but yeah, anyone else? . Hemant Kumar, you're trying to say something? Yeah, how do you tell them to understand what is 1 micrometer? Jisha, Varghese, M. Ravi Kumar, Murugeshan. Yeah, please go ahead. Yeah, how do you define a micrometer? Somebody is speaking, I'm not able to hear. Kalari Timmana? Yeah, can you answer what is a micrometer? Okay, what? Timappa, sorry. Tamil Nation.
10 power minus 6.
Yeah, 10 to the power of minus 6, that is fine. But how do you make others to understand, those who doesn't know the numbers like this? Okay, fine. So to save the time, we'll go ahead. So micro nano products are the products which have the 3D structures and which have the moving parts with the dimensions and features in the range of micro and nanometers. So thus, making them to small size is very, very important, and it is not as easy as you think. So sometimes we just write like 10 micrometers, 100 micrometers, but go practically to a shop floor and then try to achieve that tolerances or that dimensions. It is a very big challenge. But these kind of a trends have been happening. It is called as miniaturization. So where earlier the products were very big, but nowadays with the micro manufacturing technologies, we are able to make them to a small scale. So good examples for this kind of a miniaturization is like our computers, our cell phones. So the first computers were so huge that they were like a big room, but now with the help of this miniaturization technologies, they have been made a very, very small, portable, and very powerful. So these are the trends which have been happening. And you know what is the inspiration for these kind of inventions and to go forward in making these smaller components is the nature. So it looks like there is a wasp, which is a small insect, what you see here. So that wasp has a zinc tipped tail. So it will be something like the tail, and the tip is made with zinc, and it will be able to drill the holes very, very small diameter in the wood or the trunk of the tree. So, and when the scientists actually observed it, they found that the tail will be like very flexible, but whenever it want to drill the hole, so it will pump in the fluid and it becomes stiff. So once it has become stiff, it starts rotating the tip at a very high frequency. So it is something like a vibration plus a kind of a rotary motion. So then there'll be a small zinc tip and then it starts drilling. And whenever the hardness of the wood is higher and if the zinc is about to break, you know what happens? The zinc tip will not break, but actually the tail will just bend like this. So that means before the tip breaks, the tail actually bends and then releases the forces. So thus, during the lifetime of that wasp, never the tip breaks, even when it is trying to drill the hard material. But actually, to achieve this kind of a technology in micro machining, even after so much of research, so we still find it difficult. So we have small tools which are of the order of 50 micrometers, 40 micrometers, which are smaller diameter than the hair. So many times when you make a mistake, even before it starts machining, they break. But for this one, the tip never breaks because they have that kind of a flexible tail. But we try to introduce that in engineering. Still, there are several challenges. So you need a flexible kind of a shaft, so where you can limit the load and still achieve the torque which is required to drill the metals. But that technology is still a challenge. So thus nature has. And also like another inspiration. So we talk about what is called as a micro gears these days. So where we have small gates and we can transmit the power through that kind of a gears. But you know, in nature, so this is there in the Scientific American Journal, that video is there. So there is no provision to download that. So probably you can use this link or put this title. So mechanical gears in nature, if you put like that, the website will come, or you can use this address. You can see the video, how the small insects has a gear kind of a structure in the hind legs, that is the behind legs, and it locks these legs before it makes the jump. Okay, so thus, though it is a small insect, but it can jump longer distance because of these kind of gear technology. So they were all there in the nature, and even many of the medical robots, what we see, they're all being inspired by the human. So thus in the creation, so there are all these secrets and we are trying only to implement them. And of course, artificial intelligence is nothing but mimicking the cognitive capacity what the human beings has. Okay, then if you look at the technology, I hope most of you are mechanical engineers and you can understand these things. So generally these topics, each of them, if you take, it takes several hours to complete, but I just try to put these technologies in a slide. So like mechanical micro machining, so where we can use the physical tools. I'll show you some of the same images. So probably, okay, sorry, you can understand here. So these are like few micrometer tools. These are all same images with what is the magnification? So something like 500 times 180 times 183K. So that is the order of magnification with which you are seeing these things. So they are actually the cutting edges because it is magnified. So for us, it looks like blunt, but they are the cutting edges. So thus we can use that small mechanical components, mechanical tools, and we can manufacture the micro products. Then focused ion beam. So you can remove atom by atom the material and you can make the shapes like nano pillars, nano cones and structures. Then lasers are one which are being very popularly used. Actually, we have a laser here at IIT Madras under a project, what is called as a femtosecond laser. So they come under what is called as ultra short pulsed lasers. So they are very powerful. We are actually trying to machine titanium, Inconel and other types of difficult to machine material. But these lasers are so powerful, you put a pulse of laser on that, that material, even though it is a difficult to machine material and high temperature material, that means its melting point is around 1500 and above, but it doesn't even melt, but just evaporates when you put a pulse of this kind of femtosecond laser on that surface of the metal. So that powerful they are. So lasers are very popularly used. Then we have EDM, electromechanical, um, electrical discharge machining. Then we have chemical machining, ultrasonic machining. So then some of the lithographic kind of techniques. So they all come under what is called as MEMS technologies, micro electromechanical systems. So under that technologies, we can manufacture. So thus there are several technologies these days, even 3D printing. So they started printing the micro and nano components these days. So thus we have several technologies by using which we can make the micro products. So because of these kind of a products only, we are able to make and change the whole medical field. So some of the examples I'll give, and then later we'll be talking about the medical robots. So earlier, when we were children, so whenever we make noise in the class or even in house, so the teacher or parents used to threaten. So if you make noise, we are going to put injection. Why? That is the most painful experience every child probably would have gone through. So when you say we'll put injection, they'll sit silently. They're afraid of it. So that's how it is. But nowadays, we have what is called as painless injections. How is it possible? Mosquito is the good example. You know, when mosquito is biting us and when it is sucking the blood, we'll never notice. And sometimes we'll feel the itch. You know, that is not because of the bite of the sting, but that is basically due to the chemicals which it releases. Okay, so thus why it is painless? Because the diameter of the sting is very, very small, so we can't even feel the pain. So thus even if injection sizes, diameters are made small, then it will be painless. So nowadays it is possible actually to make these kind of a micro needles. So thus injection process have become very much painless. Then you would have heard about the laparoscopy surgeries. So it is called minimal so insertion. So you don't have to cut much. So only a small portion will be cut in the body. Then all these devices, so like a camera, then depending on the surgery, it need to carry something like, yeah. Anything else? Somebody want to say something? Okay, so different devices can be sent inside, then the surgery can be carried out, then these instruments will be withdrawn. Then nowadays we have actually what is called as a pinhole surgery. So where you can just make a small hole. So what you are seeing here, as small as this, and then by using that, so the small pinhole there, and using that we can carry out the surgeries. So these are all possible because of miniaturization. So there are products actually what is called as blood filters. So we bought actually one machine to make the micro machining by using the conventional tools, and the name of that company was Kern from Germany. So when we were purchasing that machine, so the engineer from that came and demonstrated these things. So these were called as the blood filters. So wherein you can put these things across the arteries which are leading the veins which are leading the blood into the heart, and we can allow regular blood cells to pass through these holes, but stop the fat so that it's not going to go inside the heart and damage the heart. So these are all possible when you can make these holes exactly to the required size, where it need to allow like RBCs, WBCs, and regular blood cells, and stop the fat particles which are generally will be agglomerated. That means they stick together and they'll be larger in size. Okay, then this is called as a lab on a chip. So why it is called lab on a chip is when you go to the blood test, so generally they take one tube of blood, test tube of blood, and then they carry out only one test. But here, by putting few drops of blood here, so we can carry out different tests in each of these chambers. So that is the reason it is called as a lab on a chip, and the size of it will be something like an ID card. So the right side one, what you see, so this is what we actually machine by using our facilities here in IIT Madras. So thus we can make a small kind of a chips. You can look at the size of these things. So we can make 0.6, that is 600 micrometer size, and even you can make a smaller them. So these are the cutting tools which already I have shown. And we can actually talk about laser and other methods, how we can manufacture the components by using these technologies. So if you are interested, you can look at some of my papers on EDM and laser, and also in the cutting tools, so where we have been using these technologies for making the features. So rather than making the products, so we have been looking at the technology side of it. Okay, now coming back to our medical robots. Yeah, in the meantime, is there any doubts or questions? Any doubts or questions? Just 1 minute, I'll take a break. Yeah, you can tell, keep answering it. Any questions or doubts? Even during the lecture, you can ask if you have any questions. Or now also you can ask. Any questions? Okay, so if you don't have any questions, we'll go forward. So these are some of the robots which have been practically put to use, and they have been working in the medical field. So we'll look at them one by one. So in 2000 itself, so this robot has come. The name of it is Da Vinci. So each of these robots actually work in different fields. So thus we have taken the examples, one robot and one function. So now this is actually a robot which can help in what is called as minimally invasive approach. Okay, so even when I was trying to tell about the laparoscopic surgery, so this is what it is called, minimal invasive approach. That means the cut will be very small, but the whatever you want to carry out, so that function is done. So earlier, if you want to remove probably a kidney stone or something like that, we need to make a big cut, 7 stitches, 8 stitches we need to put, and then remove the stone. But nowadays, just a small 1 stitch, or even for pinhole surgery, you don't even need that stitch. The skin itself will just close. That small, we can have small incision and insert all the instruments inside and carry out the surgery whatever you want. So that is called as the minimally invasive approach. And this robot has been working, though actually there were some issues. So there were some mistakes which are made by the robot. So that is the reason always it will be watched by the surgeons. So we don't leave robot, the patient into the hands of robot. So the medical doctors will be there, they'll be looking at it, and if at all they feel something is going wrong, immediately they will intervene and then correct that. So here you can see the video where the robot is carrying out the surgery. Can you hear the sound?
Yes, sir.
So robotic arms remotely controlled. You can put whatever the device we need. If you want to cut, you can put a rotary kind of a tool there. And it is controlled by the surgeon. It is inside the human body. So this is outside actually. So the same procedure is being carried out inside. They can control the movement of the robot by using the hand movements outside. It is putting the switcher there inside the body. This is that robot. Different configurations. Yeah. So then the next one, it is called actuated and sensory prosthesis. So probably you'd have heard this term. So where when legs or hands are amputated, so they fix the artificial leg limbs. So it is called limbs. So prosthesis, they are called as, and then the human being can carry out the work, not exactly like hand, but almost similar to what the regular hand functions. And nowadays, people have been studying the brain activities and they are trying to convert the brain signals into a physical activity. Now, for example, so in the brain, if I say, okay, lift my hand. So when we have God-given hand, we generally do that. But if it is a prosthesis, they need to put a lot of effort and do that. But now if you can connect the signals, so even without effort, when you tell mentally lift this, so it will be actually lifted. So still kind of research is going on, but here like a physiotherapy, and after practice, so they try and then to be as normal as possible. So on the top side, what the video you can see is practicing with that prosthesis, artificial limb hand, and then later he will try to hold the things. They will get adopted. They may not be able to hold like our normal hand, but still they'll be able to carry out many of the functions. Then in the bottom side, you can see the prosthesis legs, so artificial legs. So many times I think when we were children, we used to read about the stories about people going into a war, losing their legs, and when they come back, they have to spend the whole time on a bed or in a wheelchair and all. But nowadays, it's not like that. They can actually fix these kind of limbs and try to live mostly the normal kind of a life. So MIT Biomechatronics, Massachusetts Institute of Technology in US, so their biomechatronics lab, so they have developed some of these kind of actuator and prosthesis which can help in human beings. So even in IIT, this kind of a work is going on. Probably you would have seen in some of the news, so where a standing wheelchair which helps the people to get up more easily, and there are some videos you can search for that in the Google. So you can put standing wheelchair IIT Madras. If you put, you can get some of the things which have been done here at IIT Madras. Okay, then endoscopy robot. So bot means robot. So usually, if any of your family members would have gone through this, you will understand how painful this endoscopy procedure is. Actually, whenever there is problem with the colon or the intestine or in the stomach, abdomen, so what they do is they take a camera, which is a very big size, and then they insert it through the throat, and then it goes inside the stomach, and then it looks around, and we can see inside the stomach on a screen. And this camera used to be a bigger size, and they used to put a jelly inside the mouth, and then they'll push it so that it can go very smooth. And patients are more afraid of this procedure rather than even the surgery. Surgery is because they give anesthesia and you don't have to, you will not know much. But this is more done like a live, and it's a very painful process. So that's what I heard from the people who has undergone. But now we have actually what is called as an endoscopy capsule. So it will be something like a size of a capsule, which the patient can swallow. Then it will have the cameras, tiny cameras. It will go inside, and then we can see whatever regularly what we want to see inside the abdomen or the intestines. And finally, it will come out. So thus, it is a very, very simple process and less painful. So that is possible because we are able to manufacture and make those minute or mini cameras and all the devices, transmitters, everything has been packed into this capsule size module, and we can send it inside the human body. Then orthosis, so this is another type of mobility, helping the people to walk and teach them. So you can see here, so we can help them. So those who have orthosis, so it is a type of weakness, so where they cannot do the regular works, but we can give the help of the robot. You can see here, and they can practice and try to live a normal kind of a life. Then targeted therapy is another very advanced kind of technology which has been introduced in the medical field. So what is targeted therapy means? See, for example, if there is a cancer tissue or a tumor somewhere inside the stomach, you give actually injection, that is chemicals, then it goes into the whole body, and some part actually reaches that particular tumor, targets it, but at the same time it goes through the whole body, and then the whole body gets affected. Probably you might have seen some of the cancer patients who have been suffering because of these kind of treatment. So, but instead of that, actually, what we can do is we can deliver the drug exactly in the place where the tumor is there. So in that case, the tissue or the body in the other places need not be damaged. We can deliver it only to that particular spot. And how we can do that is, again, we can make a micro kind of the capsule where you can put the drug inside, then you can send it into the body. So it will go and attach it only to the place where there is a tumor. So I think based on the chemical affinity and other characteristics, so you can make them. So once it gets attached to it, it starts releasing the medicine slowly. So thus, it's actually possible. So even in diabetic patients, slowly to release the medicine, they use these kind of technologies. So they wear a small micro needle strip. So then usually what happens is whenever they eat the food, the insulin level shoots up. So whenever they take the injection, it comes down. So then it will be like a cycle, which is not a very good process. But then if we can release the drug whenever it is required slowly, not just taking an injection in the morning, then by the evening time, so again the sugar level shoots up. So instead of that, if you slowly release it, so the sugar level will be maintained at a particular level, which is a more healthier for the patients. So these kind of things are possible. Then disinfectant robot. I think these kind of things are nowadays being very much used in COVID kind of a situation where people don't want to go near to the patients. because of they getting infected. So we can have this kind of disinfectants, so where generally UV lights are used, or now we can have even chemicals put into that, and we can ask it to go and spread in the rooms or hospital rooms, or even in the operation theaters in other places where human beings don't want to go. So these are called as the disinfectant robots. You can see the video of one of the robot performing this kind of a task.
Microbes are everywhere. As places for disease treatment, hospitals are susceptible to microbial contamination and patients are prone to cross-infection. In recent years, a large number of newly emerged multi-drug resistant bacteria, such as methicillin-resistant Staphylococcus aureus and Carbapenem antibiotics-resistant Acinetobacter baumannii, have led to frequent healthcare-associated infection, HCAIs, serious threat to human health. Reports show that 4 million people get nosocomial infections in a hospital in China every year. The existing methods for air and object surface disinfection are time-consuming and laborious. The time of disinfection and the amount of disinfectant solution cannot be accurately quantified. The quality of disinfection is difficult to guarantee, and it is easy to cause occupational injury. Ultraviolet lamp disinfection requires manual movement and operation. Even ultra-high-intensity ultraviolet lamps can only kill very close bacteria. Bringing artificial intelligence technology into the field of disinfection, TMI Robotics Corporation has developed the world's first intelligent multi-mode disinfection robot. The TMI Intelligent Disinfection Robot takes the mobile robot platform as the carrier. Equipped with 3 disinfection modules, the ultraviolet lamp, the ultra-dry fog hydrogen peroxide generator, and the plasma air filter. It can meet the various requirements from hospital. The TMI Intelligent Disinfection Robot can automatically plan a path and navigate to the destination. Based on the AI environment recognition technology, it can automatically calculate the working time for disinfection and identify critical objectives. Before disinfection, the TMI disinfection robot prompts people to leave by light and voice. Then it starts the PM2.5 detection and the plasma air filtration module. If excessive humidity is detected, the robot will turn on the drying mode to reduce the ambient humidity. If the air quality is qualified, the robot will enter disinfection mode, in which the ultra-dry steam generator starts to work. Quickly increase the concentration of hydrogen peroxide in the space. At the same time, the UV lamp starts to work. Quickly generate the hydroxyl radical. Because of its good dispersion, extra dry steam can thoroughly disinfect. During the disinfection, the robot can real-time detect and precisely control the concentration of hydrogen peroxide to guarantee excellent disinfection results. Based on its mobile platform, the intelligent disinfection robot can divide a large area into several small ones to achieve accurate and high-level disinfection. Multiple microbial killing tests have proven that the TMI disinfection robot can use standardized and intelligent means to help hospitals to reduce the incidence of nosocomial infections and meet national standards. The robot is proven to kill 99.9999% of common bacteria, including multi-drug resistant bacteria, fungi, and viruses, fully meeting the high-level disinfection standards stipulated in the regulation of disinfection technique in healthcare settings. The disinfection robot, put into clinical application, can shorten the disinfection time by 40% to 70% and improve the labor efficiency by 30%. The TMI Intelligent Disinfection Robot can disinfect around the object without dead angle. It realizes the quantitative and traceable management of disinfection tasks while ensuring the occupational safety of clinical staff and nosocomial infection professionals. As intelligent disinfection platform, TMI Disinfection Robot achieves quantitative, information-based disinfection, traces the disinfection task throughout the process, and realizes the closed-loop management to help hospitals carry out intelligent disinfection and nosocomial infection management.
Okay, so these videos are taken so basically to see their application. So there is no commercial interest here. They are all taken from the public domain. Okay, so as we move on. So next one is a clinical training robots. So here these robots offers a more realistic, functional and easier to use learning interfaces. I don't know whether you know this. Generally, whenever the surgeon makes a surgery, if it is a complicated one, unique one, and for the first time if they are doing, for example, if there is an heart patient and some procedure need to be carried out which they have never done before because it is a special case. So what they do is, actually nowadays we have rapid prototyping, or rather additive manufacturing techniques, where they make the same, they take the scan, then make the heart same like that by using a different materials, and then they cut that material and practice the surgery, because the time available to carry out the surgery will be very specific. See, when they stop the heart and then use the lung heart machine, so you cannot just keep it for quite long time. So something like 1 hour or even less. So before that, they need to complete the surgery, stitch everything, and then make the heart to function again normally. If it is delays and all, sometimes it will never restart. So it's a very, very risky kind of a process. So to make it to do it faster, they first practice on these kind of a dummies, and then later they do the actual surgery. So in that kind of a cases, the training robots will help in making and doctors to feel the realistic thing, like even how much is the pressure they need to put. So if they put excess pressure, the tissues below it or any parts below it will be get cut. So that is the reason the surgeon's scalpel, they need to handle it very nicely. Like for example, if they want to cut the skin, only at skin level they need to cut it. They put it sharp and then just cut it roughly, the organs inside will get damaged. So they don't do that. They just cut it exactly to the depth what is required. So all these things can be practiced with the help of the training robots. And another robot which is being used is called as a companion robot. So generally and specifically now in COVID patients, so nobody can go near, even though parents are there, their loved ones are there, but nobody will be allowed to come near. So the patients already they are sick, they'll be afraid what is going to happen, and there are nobody to care for them. Nobody comes near. Even when people come near, they stand at a distance, so give something and go away. So they feel very desperate. So in that kind of a cases, these robots will act like a friends. So maybe like a doll shape or whatever. If somebody likes a teddy bear, so make that robot in the teddy bear shape and then give it to them. So it talks and then interacts with the patients and gives them company for 24/7. So thus, there are different types of robots. Alexa is one which speaks and then tries to give you company, but you can make it in the form of a doll and then make it feel more realistic. Then the other one, telepresence robot surrogates. So here, generally what happens is, we'd have seen, like even in a mechanic, if you go to a shop, sometimes it is a simple job. The main mechanic will not do the job, but he'll be standing there looking at the junior person or training, the person who is getting the training, and he'll be telling them whenever they're doing wrong, they'll say, okay, do it like this, that. So even the medical also, it's like that. When younger surgeons are carrying out a surgery, the senior doctor or an expert doctor, he may not be physically present there because of distance and other things. So now we can have a tele-robot where it will represent exactly like the same robot, the same like the expert surgeon. He'll be there in the operation theater looking at what these people are doing. And there in the remote place, the surgeon also will be looking there and he will be guiding them. So in case they are going wrong, so immediately this robot will intervene and then tell, so do it like that. So thus telepresence. So they are almost like an expert is present in the surgeon, present in the surgery room or operation theater. So many times we'll feel comfortable when our guru or like a senior mechanic or a senior surgeon is with us, or even sometimes when our teachers are there with us, we do the work confidently. So thus the telepresence robots will help in that way. And then robotic nurses. So all the functions which the nurse will be doing, so the robots can do. So me, rather than explaining it, you can look at this video and understand it much better. Changing the sheets, medicines, giving medicine. Okay, so thus whatever the job done by the nurse, so the robot can do. And then pharma botics. So actually, if you look at the warehouse, even for generally in industry or even in pharmaceuticals, so there are big kind of packages you can see here. So they'll be stacked like in a 3D space to pick up something what is required, or even in a pharmacy. So when you go to a medical shop, so the person looks at the slip, then goes and picks up the right medicine and then bring. So if there are people who are newly appointed, they'll be keep searching all the racks for the medicine, and then the senior person, experienced person will come and tell, oh, not here, go look there, so he can find that medicine and he can bring. So these robots can actually help in picking out that kind of the right medicine. So wherever it is located, it can know and then it can bring and give it. So thus they are much helpful. In industry, we call them as ASRS systems. So ASRS is nothing but automated storage and retrieval systems. Automated storage and retrieval system. So the same thing even for pharmacy. And these days the medicines need to be stored at minus degrees, so lower temperatures. Even the robot can go inside, but a human being to go into minus 70 degrees temperature, like COVID vaccines, some of them need to be stored at that kind of a temperature. So you can't go inside and then bring it. So you can send the robots and ask them to bring. So all these functions can be done by the robots. Then the next one, the diagnostics. So usually like when you do the blood test and other things, so we need to diagnose what is wrong. So even that can be done by the robots. So they have nowadays actually a lot of data mining kind of functions are done, though there is a large amount of geometrical data and then readings from several instruments. So it is possible for the robot to analyze it and then say, like for example, if you take a patient on an emergency, so first they'll connect all the things. So they'll read the pulse, they'll check the breath, they connect the machines and continuously monitor that. Then by looking at all the readings, doctor can say what is the state of the patient. So even here, the robots can get all those signals and analyze, and they can tell what is the issue. So this is called as artificial intelligent diagnostics. Then robot assisted biopsy. So it can do surgeries, it can do biopsies, but this particular robot was designed to do the biopsy, to take the sample from the heart and then use it for testing. Then the next one, AI epidemiology. So where this kind of epidemics, so viral infections, analysis and presence of these kind of viruses. So the systems can see and detect them and caution. And also you have seen in cleaning those things. So we can use the artificial intelligence. So these days actually to find out the medicines and the vaccines, they study the whole DNA structure and a lot of data will be generated. So that can be analyzed by using artificial intelligence. Then the 15th one, so antibacterial nano robots. So we can send these small robots inside the blood vessels and then they can carry out the work for which it is intended. So a small robots, so it will go into the platelets and then they can carry out, clear the bacterial infections or even remove the fat which is deposited on these blood vessels. So if the fat is deposited, they can go and remove that. So they'll be so small that it can go into the blood vessels wherever it is required and carry out the functions. So there are several advantages of these medical robots. So even the diagnosis is very fast. So earlier and all, if you take a CT scan, till the doctor reads it and tells, we will not know what it is. But nowadays we see that the report, initial report is generated immediately because the robots or the artificial intelligence system analyzes it and gives the first report. So later doctor comes and looks at it and then he will give the final decision. So then the robots doesn't get tired, they won't get infected. So you can use them wherever you want. Okay, so we'll see some of the robots, how they are carrying out these surgeries, and then we'll close.
A robot operates on a medical emergency. A scene from a science fiction film? The fiction has long been a reality. In the hospital, the robot becomes the perfect teammate of the human being, like the Da Vinci. We can preserve fine structures. We have a three-dimensional view. We have a tenfold enlargement of the surgical area. We have instruments that are superior to the mobility of the human hand. And we can operate without shaking.
Und wir können zitterfrei operieren.
No wonder that medical robotics is booming. Employees at the German Aerospace Center are developing a robot that will revolutionize surgery in the future, the Miro. Thanks to its lightweight construction, it can be integrated into the operating theatre in a very space-saving way. Furthermore, the research also includes the fact that even more can be discovered about the patient's insides via miniaturized sensors. And this information actually corresponds to the different senses of the surgeon. So it's tactile, haptic, auditory, and also visual. This also improves patient safety. Suppose the hand of the doctor ever slipped off the controller. A life-threatening scenario. Not with the Miro. It can be programmed in such a way that the patient's organs are not put at risk. So it would not carry out an accidental movement by the doctor. So will doctors soon become superfluous? After all, more and more machines are being developed that will work autonomously. The robot arm at the Fraunhofer IPA, for example, is designed for tissue sampling. The experts agree, however, that the medicine of the future will always need experienced doctors. Robot-supported assistant systems in medicine are just that, tools that assist. So a doctor is always fully responsible for the entire procedure, and the robot is merely a tool.
Hello, I am Dr. Fernando Diaz. At Beaumont, our neurosurgeons are known for giving our patients the most innovative and minimally invasive options for surgery, and that includes robotic-assisted surgery. Robots assist surgeons in placing the instrumentation in a very precise way. In neurosurgery, we primarily use it for spine surgery. The basic idea of the robotic technology is similar to what you use in your car with GPS technology. The precision comes from planning the surgery ahead of time on a computer. We tell it exactly how we want the instrumentation to be placed. Then the robot helps reproduce the same planned surgical approach with the GPS technology that in surgery is called stereotactic guidance. Beaumont neurosurgeons are now using the Mazor X robotic technology in thoracic, lumbar fusions, and in sacroiliac joint fusions. It also can be used for the treatment of tumors or cases involving spine fractures of any type, or an application for degenerative changes of the spine. This tool allows us to accurately and safely place the instrumentation we use during your surgery. Once the planning is complete and we know exactly where to place the instruments, the Mazor X saves the instrumentation during surgery. The Mazor X reproduces the same plan with precise stereotactic navigation by recreating the planned trajectory for the patient during surgery. The benefits of this technology to our patients are: number one, a dramatic reduction in radiation exposure because we are able to limit the use of X-rays. Number two, a customized surgical plan for each patient before going into the operating room. Number three, increased accuracy and safety in the placement of the instrumentation. Number four, less time to complete the spine surgery. And number five, a reduction in potential complications resulting from misplacement of surgical instruments. So you can see, the Mazor X technology provides our patients many benefits to improve outcomes. If you have any questions about the technology or any surgical option at Beaumont, please be sure to talk with your surgeon.
Okay, so though there are several challenges, so there were some issues with already existing robots, but still, so we have been seeing that more and more these robots are being put to use in practice and being implemented. So if the technology is even perfected, so we see the whole revolution in the medical field, so which is already been happening. So thank you for your attention, and if you have any questions or if you want to interact, you can do that. Thank you. Any questions?